Ladies and gentlemen, we are glad to present you the scientific work titled Applying a CDIO Approach at Technical Universities, which was carried out by the team of researchers from Vinica and Zhytomyr, Liudmyla Martseva, Larysa Movchan, Tetiana Vakaliuk, and Dmytro Antoniuk. The reason we have addressed the issue of a CDIO approach training engineers is labor market globalization, which sets a totally new range of requirements to the graduates of technical universities. Nowadays, employers expect modern engineers to create innovations, run enterprises, organize businesses, develop and launch innovative items to the market. However, today's graduates lack proper communicative skills, the ability to work in a team, practical skills to create objects and processes. This discrepancy between employers' requirements to more practice-targeted training and the outdated theory-focused syllabi call for changes in the format of education. The topicality of this issue is undeniable, because nowadays the CDIO approach is supported by over 120 universities from 30 countries of Europe, Asia, Australia, and New Zealand. Our research aims to analyze the implementation of the CDIO approach in modern professional engineer training. The main feature of this approach is to practice targeted engineering training, while the main aim of modern technical education is training for successful professional activity in the conditions of increasingly complicated production technologies. Nowadays, Ukraine is trying to establish competitive, high quality education according to the requirements of innovative, sustainable social and economic development. CDIO approach can be a good aid in doing it. CDIO approach, which means conceiving, designing, implementing, and operation, and its main peculiarity is practice-oriented training of engineers for successful professional activity in the conditions of increasingly complicated production technologies. This complex approach enables to reform professional training of students of technical universities in the context of innovation, leadership, and entrepreneurship. It also helps to modernize syllabi, teaching methods, and the infrastructure of universities and involve specialists of the technical sphere into all stages of the life cycle of objects, processes, and systems, designing, planning, production, and use that meets the requirements of the society. Here, suffice it to highlight the principles that would enable its successful realization. Since we consider engineering training as a complex set of tasks in the context of real engineering practice at production, this requirement sets the first principle that assessment of obtained knowledge and skills must be complex and take into account their applicability in unfamiliar situations. So future engineers must be able to apply basic technical knowledge in practical activity, manage the processes of creation and exploiting engineered systems, objects, and other devices. The second principle is that the training outcome should conform to the CDIO standards presented in the list of graduates' competencies developed with employers' involvement. However, it was not until the 1990s when the value of practical skills for modern engineers was given proper attention as demanded by manufacturing companies that were dissatisfied with the level of training of graduates at that time. Nowadays, much attention is paid worldwide to engineer training with competency-based approach. For example, standards of the accreditation board of engineers training in the USA, competency standards for engineers in the UK, SPEC. In Great Britain, project EUR ACE on accrediting engineering syllabi and graduates all over Europe. Requirements to the syllabus assessment of the Canadian Engineers Accrediting Council. So for manufacturers, an engineer must find potentially successful economic solutions, have understanding of their profit to the society, and be able to cooperate with other specialists. In this regard, suffice it to note that the CDIO approach unites four interested parties whose interaction defines the quality of the outcome. So students seek to develop necessary competencies for their better employment and successful professional activity. Teachers, on their part, and universities must create a specific educational medium close to real working conditions. Naturally, employers are seeking to hire specialists ready to manage the process of creation and exploiting engineered systems, objects, and other devices. The role of public organization is to benefit from engineers understanding the importance and deeper impact of the scientific technical progress on the society. The interaction of these four parties creates a specific learning medium with maximum students' involvement and responsibility. But students cannot learn to apply cognitive structures that they haven't developed yet. Therefore, the CDIO approach at the context of modern engineering training takes into account all the stages of the life cycle of engineering solutions, which include planning, which means the analysis of the demands of the interested parties, choice of technologies, consideration of valid norms and regulations, concept development, and business planning. 2, designing, so in other words, a detailed project description, drafting and composing algorithms describing the final objects, processes, and systems. Production is project transformation into real objects, projects, or systems, including all stages of production, testing, and checking. Application, in other words, effective use of the produced item, process, or system, including maintenance, testing, and checking, also improvement, change, and dismantling. So the application of CDIO approach means the transition to students' integrated teaching aimed to create products, processes, and systems. These goals are defined in the main document on reforming syllabi for engineering education, CDIO syllabus. CDIO syllabus is sort of a list of employers' requirements to the professional training of technical specialists, engineers. It includes a list of lacking skills and abilities of graduates and must-have competencies. It includes, the most important for the employment skills are effective teamwork, information analysis, effective communication, collecting information. The lacking skills are the following: running business, managerial skills, project management, quality management, the knowledge of marketing principles, and professional ethics. A CDIO syllabus comprises all these skills and abilities and is targeted at their development. It is a framework for the development of curricula and is used for the description of specific knowledge the students must obtain within engineering courses. It comprises the following chapters: subject knowledge and comprehension, embraces basic scientific knowledge, fundamental engineering knowledge, profound engineering knowledge, methods and means. 2, personal competencies and professional skills. So analytical thinking and ability to solve problems, experimenting, research and obtaining knowledge, systemic thinking, professional competencies, and personal qualities. Interpersonal competencies include teamwork, sociability, foreign language, communicative competence, and planning, designing, production, and application of systems within the enterprise, society, and environment as an innovative process. External and social environment context, business context, planning, designing, production, and application. The presented CDIO syllabus has a complex nature and in comparison with the national accreditation criteria for engineering syllabi in other countries, enables us to fulfill a broader task, helping to define the ways of improving valid curricula. A CDIO syllabus is also designed taking into account different levels of human cognition. For instance, according to the famous Bloom's taxonomy, training embraces three spheres: cognitive, which is knowledge and thinking; emotional, personal qualities and values; and psychomotor, movement skills and actions and manipulations. Therefore, we differentiate the most significant skills for the graduates: engineering, thinking, communication, designing, and personal competencies, which can be developed through project-based learning in laboratory experiments or ICT designed experiments and the assessment of their results. This is already realized by the School of Machine Building and Aeronautics of the Royal Institute of Technology, Stockholm, Sweden, which offered the first-year students studying fundamentals of engineering to design and assemble a race car. While carrying out these tasks, the students produced classic chassis according to their drawings and modeled the body of their car. After that, the race cars assembled by students were tested to define the failures and strong points. The students of the Massachusetts Institute of Technology had to design two independent 2-kilogram robots able to communicate in space. The project involved 15 students who designed and created prototypes, power plants, navigation, monitoring, and control systems, then tested in the conditions of zero gravity. To estimate the level of developed competencies of future engineers and their readiness for professional work, we researched at the Zhytomyr Polytechnic State University, comparing the performance results of bachelor's and master's. For the research, we used the results of the methods of social pedagogical analysis, performance monitoring, experts evaluation, pedagogical observation, questionnaire design of both students and teachers. Such methods are quite popular since they conform to international standards of teaching and learning results at university and developed competencies of future engineers. First of all, we diagnose the bachelor's and master's levels of proficiency in certain competencies according to the 100-point score. See the chart, please. The results of estimating students' competencies, average rate for students participating in diagnostics, showed that the majority of future engineers have sufficient fundamental knowledge, can work in a team, possess necessary communicative skills, but are not ready to provide analytical substantiation of any engineering problem, are now enough knowledgeable about experimental research in the engineering entrepreneurship. Questionnaires analysis enables to state that the educational processes pays little attention to the development of these important professional competencies. Suffice it to note that in recent years, the university has been forming a new educational medium aimed at active cooperation with enterprises implementing new integrated technologies, technical and informational communicative educational tools, practice-oriented curricula into the study process. After the conducted questioning, the students, we proceeded to their evaluation according to descriptors with the help of experts working at the enterprises hosting students' practical externship. The obtained results enabled us to distinguish three levels of students' professional competency: optimal, functional, basic, and insufficient, in four components: motivational, cognitive, operational, and reflexive. When distributed according to these criteria, we have seen the most and the less developed professional competency of students. This enabled us to conclude that most students graduate from the university with the basic level of professional competency in all the above-mentioned 4 criteria. 45% of graduate students showed optimal and functional levels of motivation, which testifies to their professional interests, engagement, and strive to realize their abilities. 52% of students also showed a remarkable level, functional and optimal, in the cognitive criterion of their professional training. However, the values of operational criterion were the lowest, functional and optimal, 42%, which stresses the need to intensify the practical component of the CDIO training. The lowest rate was shown in the reflexive criterion, functional and optimal, 22%, since the professional and life levels are the lowest as well, which calls for drawing more attention to students' production internship practice. The conducted research and the experience of the practical training of the university students testify to the fact that for the transition to the CDIO approach, it is necessary to have sufficient staff resources, classrooms equipped into workshops, and laboratories to create conditions for students' communication, planning, exchanging ideas, carry out experiments. The students are involved in various creative contexts, implying research and creative thinking. Students also participate in various vacancies, fairs, workshops, roundtables with the involvement of business culture representatives. The obtained knowledge will transform into skills during in-service practice. Thank you for attention.